So to do this first, okay. You have to convert RPMs to radians per second. So you would need to multiply this times 2 pi over 60, and that's how you would get it to radians per second. Hold on. Per second. Yeah, that's how you would find it. Okay. So it's 65.80 times 2 pi over 60 seconds. Because, no Pinterest. Okay, so 6.89. I'm just gonna put 6.89. So the radians per second would be, if I did 6.89. That's what it would be, radians per second. Okay. So in order to find what number to for it to land on, we have to find out angular displacement, and right now we found the initial angular speed, which is this, and now we just need time. And to calculate time, it's initial angular speed, which is this, over acceleration, and the acceleration is this, 1.100 radians per second squared. And one thing to note later on is that when we put acceleration into the angular displacement formula, the time or the acceleration has to be negative, but for this it doesn't have to be negative. So we would get what we got previously, 6.89 over 1.1. So 6.89 over 1.1. That would be 6.263. So 6.263 is the time. And I'll color code these later on so you don't get confused. This is the time. So now that we have time in radians per second, here, let me change the color right now actually. There you go. Now that we have time and then radians per second, what we need to do now is plug these into the angular displacement formula. Which is, so it would be 6.89 times the time, which is what we found, 6.262 plus 1 over 2. And then the acceleration needs to be negative, and the acceleration is going to be this right here. So it's going to be 1.100. And then the time again, which is 6.62 or 6262, sorry. And then we square it by 2. And that's how we would find this, the angular displacement. So let me see if I can, okay. Yeah, I can do that. Okay. So this is our angular displacement, 21.578. So 21.578 is our angular displacement. Let me color it. Do a dark color. I'm gonna do this one. And so we have found our angular displacement, right? So after finding our angular displacement, crap. I forgot. Wait, hold on. Okay, after finding our angular displacement, we need to, let me find the pen. We need to divide this by 2 pi. So 21.578 divided by 2 pi. That is 3.43. So 3.43. And that means 3.43 is the number of rotations that happened after our initial number, which is 13. So it's gonna do a rotation 3.43 more times. So 1, 2, and then 3. What we're looking for is the decimal place. It's because if it's going through 3 rotations, it's gonna always end up on the same number anyways. So we're looking for the 0.43. It's just cause it's already going through 3 whole ones. We're looking for what number it lands on after the 3. So 0.43. So to find the number we would have, or to find the number of spaces after 13, we would get the decimal place and then multiply by the number of spaces, which is 36, and that would equal 0.43 times 36, 15.48. So 15. Sorry, 15. This is spaces. This equals the number of spaces after the original number. Let me change the color. Okay, so we have this. So we just counterclockwise, or no, clockwise 15 spaces after the original number. So 13, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, or oops, sorry, wait, clockwise. Oh yeah, this is right. We count backwards. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it's gonna be around 28, 29. So we're gonna do this. Put the number 28 in, click the wheel, and we get our number. It's pretty close. It doesn't matter if you get it right on the number or not, because it will still accept it. And that's how you find it.